I hope you're all doing well today. Let's begin lesson 3.3, Invalid Proofs. Yesterday we learned that deductive reasoning is an argument where if the premises are true, then the conclusion must also be true. This type of argument can also be called a proof. Today, we will examine common errors that happen in proofs. An error in a proof will make a false statement appear to be true. Take a look at example 1. Liz claims that she's proved -5 is equal to +5. We know this is false. Let's take a look at her reasoning and try to identify where she made an error. Please take 30 seconds to silently analyze her work. Try to identify in which step she made an error and what the error is. Okay. The error appears in step number 1. The first premise of her argument is that -5 equals +5. This is false. -5 does not equal +5. Any deductive argument with a false premise will result in a false conclusion. Let's write that down below. This has a false beginning statement. You could also say false premise. To example 2. In this example, it appears that 2 is equal to 1. We know that is false. So we will again analyze the work below and try to identify where there is an error. This one has a little bit more to read and analyze in terms of math work. So I will give you 1 minute to silently examine the proof. Try to identify in which step she made an error and what the error is. Okay. If you didn't find the error, that's okay. This one can be more challenging to spot. But we do know something went wrong for sure, because 2 is not equal to 1. Let's carefully walk through the instructions of the proof on the left, making sure that the rules of math are being followed at each step. Step 1, I'll just highlight to identify that's what we're talking about. In this starting point, we're defining x is equal to y, which is equal to 1. Nothing has gone wrong here. We're just defining variables. This premise and this starting point is true. Step 2, multiply both sides by x. We're doing the same thing to both left and right, so here no rule is being broken. Subtract y squared from both sides. Again, same thing happening to left and right. No rules being broken here. Factor both sides. At this point, we have to actually go and look. X squared minus y squared is being factored into a difference of squares, so that's okay. And xy minus y squared, here we factor a GCF of y, so no rules are being broken there either. Step 5 is where the error occurs. Before I explain why, take 30 seconds and silently think to yourself about why, really clearly, dividing both sides by x minus y is the error. This step is the error because, I'll describe it first before we write anything down. This is the error because x minus y is actually 1 minus 1, and 1 minus 1 is equal to 0, and we cannot divide by 0. That is against the rules. So let's try and write down why this breaks the rule. X minus y is 0. And we cannot divide by 0. Okay, to summarize, common errors in proofs include the two which we've seen above, which are a false beginning or if there is a false premise. Another error, if you ever see division by 0. An example that we did not see in the notes, failing to distribute a negative. and squaring a negative. Without making it positive. That concludes the learning for this lesson. Please now move on to solving the practice problems for lesson 3.3. Good luck.